Good morning, everyone. We're Team 695, and our team project is Programmable Differential Thermostat. I'm Ogulnaz Koreskildiva, and my team members are Muhi Bigpal, Ching Huang, and Jay Nalmeli. And so today's thermostats, consumer thermostats, heating, ventilation, air, and conditioning HVAC systems have been thriving to make the energy consumption more cost reduced, and our team has decided to implement more things to the HVAC system, where we decided to add more sensors, TensorFlow, machine learning unit, more open source hardware, open source, to give more power to the user.
Thank you. Like Nazik mentioned, in the current market, the most well-known smart thermostats are Ecobee and Nest, and these two have been setting the standards of modern thermostats for past decade or so, and maybe beyond that. As for what we have thought that in their current state, most of the sensors of these two well-known thermostats are set to be inside of the house, but rather to a specific room that is located in a certain area of the house. So what we thought was we have implemented another sensor that will be set outside of the house to advise a more localized and more personalized adjustment of the user environment for the user, and have a better quality for a more personal setup.
Yeah, and so what we did was we basically we had our indoor and outdoor temperature sensors that were used in calculation with our AI, which we use was TensorFlow. We have that on a Raspberry Pi, and so by using these two numbers, we will have the program predict get a temperature that will meet the user comfort level based upon those two temperatures. And the thing with this is that, going with our previous thermostats, is that the reason why we made it programmable is because not every thermostat meets the needs of every consumer. Maybe there's like one small change they would like to add, and so we allow the user to be able to go in and add those changes, whether it be to the AI or let it be to how it calculates the temperature and how it changes it. So we give them the freedom to add whatever comfort level they want, or not comfort level, whatever code or whatever calculation or anything they want to add into the system. We give them the freedom to do that, so it's more personalized and easier for them to use.
Now we would like to open the panel for questions.
So let me ask a question. If you've got one sensor inside and one sensor outside,
Yes.
right? Can this be scaled up? Everybody's got like one room in the house, it's too hot or too cold. I mean, could you scale this by room and then maybe have that control the vents in that room so that you could do this scaled up?
Yeah, so we thought about that, and our answer to that was using 433 megahertz radios. And there's the one inside the thermostat has the capability of receiving from several different modules.
Okay.
And the outside ones can also just keep sending data to whatever address you program it to. So you can easily scale it up to at least 10 devices.
Okay. Yeah, I think that's an important point, so that literally you could have one controller in each room that could control the vent.
Yeah.
So you could try to get something consistent around the house, and you wouldn't have that.
It would be more personalized to each individual's in that location of the room,
Right,
rather
right.
than the whole entire general as a unit.
Right.
Yeah, that's what we're considering.
Yeah, it also
Okay.
wouldn't be too hard. And it's just the same schematic, you just replicate it 10 times.
Yeah.
So I had a question about, you have the metrics is machine learning, which seems like an engineering problem in search of a solution, rather than how do you measure machine learning? It's like what you're measuring is the accuracy of the predictions. So you've got, how is it measured actually, that's the actual metric that. So user comfort, again, user comfort is something
very
that is a
subjective.
goal, but it's not a metric. So, and then the results here are check boxes. It's kind of like you checked it, and what's the answer?
So here's the science behind the whole thing. We're using something called mean squared error, and that is being calculated upon the training data that we give it. And the training data comes from every time the user overrides the thermostat's temperature control. So let's say it's at 70 degrees right now, and that was predicted by the last iteration. And I went in there and I was like, I'm gonna change it to 65. So it takes 65 and a bunch of other parameters at like current point in time, like what the outside temperature was, what the humidity is right now. And it actually has a bunch of different data points. It sends it to the TensorFlow unit, and the TensorFlow unit keeps saving all this data. And the next iteration of the training data will program it so that the mean squared error is minimized, and that is how we make sure that the user is comfortable, because the initial measurement that came from the user. So that's why we say the user should be comfortable with their
Also
own
part of the-
with their own measurement.
Yeah.
It's just Bayesian statistics. It's not. It should be a probability distribution that is calculated upon the old numbers. Yeah.